Qnect software allows you to engineer and detail, automatically and in seconds, a stick model that's built in Tekla. The first time that you use the Qnect tool to make your own digitally engineered intelligent joints, you'll need to download these 3 buttons from our site at qnect.com. That's Qnect.com. Visit the download page and you'll be able to start. The next step is to open up a model. In this case, I've opened up a New York hospital that was built using the Qnect tool. For this whole building, it takes 45 minutes to make all the connections. I'll just show you a small selection here. You can see that it's a stick model. There are no connections in here yet. I'm going to highlight one particular area, like this, to select a dozen or so connections. And now I'll press button number 1. I'm going to call this Tekla Demo. I hit submit, and now the model data is going up to our secure server and sending all of the details. You still own your model. We're just extracting the data and geometry associated with it. We will individually engineer each joint and send you an email when it's done. It takes about 1 second per joint to process. So I've received the email from Qnect, so I'm going to press button number 2 now. I'll sign in, and I will see the particular job that I'm working on, and scroll down to Tekla Demo, and hit Submit. At this point, the Qnect software will download the information that we've just engineered, and you'll see that we import all of the engineered joints back into the model, fully and accurately detailed. As you can see, they're right here, all the joints that we just selected. These are not joints that you need to evaluate or change or fix in any way. These are fully engineered, fully correct joints, including all coping, welds, bolt sizes, slotted or not, with tightening considerations and more, all based on your custom preference. If I click on any particular green cone, I can see all the engineering details. So for this joint, you'll see that my reaction required is 25.55, and the capacity that I've generated is 25.7. This is a perfectly engineered connection because we iterate on every variable. Size of bolt, thickness of shear plate, weld, whether or not it needs stiffeners or doublers, etc. At this point, we can drill down to look at the strength associated with the joint. You can see the block, yield, rupture, buckling, all the flexural loading, the weld shear, and if needed, the stabilizer plate information. And then I can drill down further and see all the engineering formulas, exactly how we calculated each unique connection. This is, by the way, not a sample calc. This is the specific calculation for every single connection that we do in the building. You could stamp any level that you require, or we'll stamp our connections for you. In order to make sure that the joints are connected exactly the way the engineer and fabricator want them to be, we need to fill out the preference sheets before pressing button number 1. What I just showed you is possible because I filled the preference sheets out before the demonstration. But first, let me show you how fast it is to do a revision. Say I want to revise this beam and make it bigger. So first, I go into Tekla and choose a different size. I hit Apply and OK like you would normally, and then I hit Modify. Now what happens is our tool called the Listener pops up. The listener is always watching and listening to see if you are modifying something that will affect the engineering of one or more connections. Once it pops up, it allows you to choose between exploding, deleting, or re-engineering the affected joints. In this case, let's re-engineer the affected connections. Just like button number 1, it will ask me to enter a session name first. I'm going to put in addendum number 4, and that's how I can track the addendums or bulletins for later accounting. I'll wait a few moments for it to run. This will be super fast, by the way. I can now press button number 2, sign in, and select addendum number 4. Hit Submit, and now the fully engineered and detailed revisions are placed in the model. This allows you to instantly make the changes required for revisions, and not only that, Qnect revisions are free. Now let me show you button 3. Button 3 is called Inspect Qnect. This tool lets you review and approve the completed connections. Let's look at all of the sessions for Tekla Demo. When I click Go, it will show me a list of all the beam to column web, beam to column flange, doubler report, etc. So say you're just interested in reviewing the beam to beam double angle connections. You select it, and it will show a list. Then it will automatically create a front and top view and allow me to review those connections one at a time. It will also tell me the grid location so you can tie it back to the drawings. I can just drill through each of these, change connection types, look at all the beam to column flange connections, and just like that, I can double click to the green component cone and see all the details and engineering associated with that connection. In addition, you can also review the things that were not connected by us or the doubler plates that were needed so that you can go back to the EOR to request any changes necessary to reduce the number of doubler plates, which would save a lot of money and time. To communicate about what is connected and what is not, we use a map. Here is Qnect's map for one of the floors. This map is created by clicking button 3 and selecting the Map Radio button at the bottom of the Inspect Qnect menu. The green letters represent all of the connections completed by Quick Qnect, and the red represent the connections that are to be completed by the connection engineer. Now the detailer and the connection engineer can communicate and manage their resources more effectively. The start location is identified by a triangle and a circle right here. As we zoom out, you'll see the full range of standards connected and those that need to be connected using traditional means, all available just hours after the model has been built. Prior to this demonstration, I ran the entire building and it took 45 minutes. And now I'm going to just push button number 2 in order to load all of these connections so that you can see the model fully engineered and designed. This import time depends on the speed of your internet connection. We're almost done loading all of the connections into this model. That's 3,400 joints in just 45 minutes. That's pretty incredible. Now, of course, you need flexibility when it comes to engineering and detailing, so next I'm going to show you our comprehensive preference sheets. What if we first tried double angle, welded bolted, and then tried bolted bolted, and then tried shear plates in that order? And what if you wanted to do shear plate as a first priority? Our preference sheets give you complete flexibility to select your custom configurations and to compare many different selections for the best choice for engineering and detailing on each project. I'll get back to preference selection in a minute, but first let me show you the entire model connected. As you can see, all the welds are in the model, and here is a sampling of the 3,400 connections that were done in 45 minutes. Now let's get back to the preferences you'd like to enter in order to connect your model. First, you'd put in all of your project information, your minimum job requirements, etc. One of the most important preference choices is the forces selection. The forces that are in the model always govern. If the forces are not in the model, you have the option of filling out a table or using a UDL factor, and you can select the percentage of UDL. Here's where you would have the choice to have the New York City Integrity Code be computed automatically, and you can select the different materials you want to use and how you want to handle OSHA requirements. The one that most people find of interest is how we decide what kind of connection to try. What you're seeing is in the order of the beam-to-beam shear-only connections. You'll see double angle welded and bolted at the girder, and then you'll try bolted bolted, followed by shear plate in that order. Or you can simply change the order priority, and our servers will compute the right connection based upon your own custom preferences. And since it takes under an hour on your first day of having your stick model, you can run what we call a preference optimization. First, you would try running the job with a particular set of job-specific preferences, and then you would run it again with shear plates first, and again with different selections for the beamed columns and the beamed beams. And then you could try running with 1-inch bolts as the first priority, then try 7/8 inch bolts, then try 1 1/8 inch bolts. We have common industry costs for bolts, washers, weld inches, and plate material, so you can compare immediately and choose the most appropriate preference set for your shop and the schedule you need to meet. This alone can save many thousands of dollars compared to your usual best guesstimate. Here's Qnect's optimization report. This report is generated for every session you run. It summarizes all of the fitting connection materials with quantities of weld inches, bolts, plate material, etc., and gives an average unit cost for everything. If you run multiple runs, which is recommended, then you can compare the runs to see which one gives you the lowest cost. These runs are done within hours of the model being ready. This run started with double angle, bolted bolted as the first priority, then welded bolted, then shear plate as the third priority, using 3/4 inch, 1 inch, and 1 1/8 inch bolts as bolt priorities. As you can see here, this run had 312 shear plates, 140 doubler plates, 3,100 angles, and then we have the shear plate material cost and summary. Then we list all of the welds, the CJPs, the fillet weld sizes, the number of weld passes, the per inch weld cost, and the total weld cost. And then you can see the total field and shop bolt quantities, with unit costs for the bolts, washers, bolt installation, drilling the hole cost, and total. Then, everything is summarized here in the total costs. In addition to preference optimization, we also have bolt optimization that we call BOP. Here, I'll show you something we ran for that New York City hospital. We ran it first with a shear plate preference, and we got $633,000 as a cost for all the bolts, welds, plate material, bolt holes, and bolt installation. In this case, there were 33,000 bolts. And you could see how many doublers were needed. But then we ran it again. Remember, this is on the first day, and you could even do it during the estimating phase if that's of interest to you. And then we tried running it with double angle, bolted first, and then a welded bolted preference, and you could see that the material cost dropped to $597,000 for a savings of around $36,000. And then we try a double angle preference with welded bolted first as a top priority, and we reduced the price another $141,000 to $456,000. Okay, that's pretty good, but now we have the ability to run BOP, or bolt optimization, for even more savings. Going back to our preference sheets, let me show you where to find the preference setting for BOP, because it's very simple to use. Where it says here, would you like to take the vertical hole spacing and iterate on it, simply click yes. And instead of the commonly used 3-inch bolt spacing, we'll try 3, 3.5, 4, 4.5, and up to 6 inches. We'll engineer every unique connection for the fewest number of bolts, and therefore the lowest cost while still meeting all of the engineer's requirements. You could save up to 40% of the bolts required on a job. Bolt optimization saves $112,000 on this project alone. So just by executing a few runs, and they can even be done simultaneously on your first day, you could reduce the cost from $633,000 to $367,000 in connection materials, while also reducing the number of doublers by 300 or so. You can see the dramatic price difference, and then you can decide how to proceed based upon digital intelligence. This is software as a service, so we charge a fixed fee per connection. There's no charge for revisions, there's no upfront cost, and no maintenance fee. Just contact sales@qnect.com, and we could send you a project quote. Thank you for listening. Intelligent digital connections are finally here for Tekla users.